Hi there, this is Jacob Nash Precalculus Lessons, and this is Unit 3, Lesson 2 on graphing logarithmic, can't even say that, functions. So I'm having a not super fun time recording these on this Friday evening that I don't necessarily want to be recording precalculus lessons on, so I have to have music to make me remain calm. The music should be quiet enough, but if you can tell what it is right now. Right now, it's playing a Black Keys song, so all credit to any music that plays. But I'm trying to have it quiet so I don't get like copyrighted or something. If it even shows up, I don't know. But anyways, here is it's like the parent function, but with the transformations in it. And this is no different than any other transformation. You just have log in there. So usually we have A, B, C, and D, but we have to have A, M, C, and D because B is already used for base. But we'll talk about what happens if the base is different, but it's no different for A, M, C, and D as it always was. We can have vertical stretches, compressions, reflections over axes. We can go left, right, and horizontal stretch compression. So you can see what those mean, but I've already said that before. But logarithmic functions have a vertical asymptote. Remember, the exponentials had a horizontal. So, for example, this is what an exponential one might look like. But instead, we have a vertical one this time, and this is what a logarithmic one might look like. So that's a little bit different. So if we have a base that's greater than 1, then it will look like that. If it's less than 1, then it will look like the second one. Just keep that in mind. So we have one problem here, and we're going to try to find all these things. Okay, first thing, standard transformation form. So let me rewrite it up here. Of f of x not showing up. That's just what I need. Oh, I made it too high, that's why. Let's try that. Oh, still a little bit too high. Let's do that then. So we need to first move, hopefully you can see my mouse, this -2 to we need to move that to the other side, but we can still have this -3 log 1/3. So that's the base. 1/3 is the base. So now we're going to have a decreasing log function. And so why this 3 doesn't have to move is because it's on the log without a plus or minus, so it's not being added or subtracted. So now we have the 9 minus x. Let's change that to -x plus 9, but that needs to be... How did that end up black? Weird. But we need to factor out that negative, so divide it out so that when you do that, it just changes the signs of them. So there we go. And then we have the -2 on the end. There we go, we did number 1. Asymptote. I think I forgot to say it, but asymptote is always going to be whatever the horizontal transformation is. We see we have a -9 here, but we have to change that sign to make it positive. So we have a vertical asymptote of x equals 9. Y-intercept, what we do is we set x equal to 0. So as we can see from down here, those right there, that x, if we set that equal to 0, here, let me just move this over. See that? Okay, let me get this going. Okay. Gotta write down the thing here. So we have this 9 minus, and we're plugging in 0. So that becomes 9. And we can focus just on this part right here, the log part. So now we're looking for what x is in this case. What 1/3 to what equals 9? Well, 3 to 2 equals 9, so -1/3 to -2. I mean, -1/3 to -2 equals 9, because that would distribute and make it be this, which would mean that would be 9 to... just never mind. That's not the right way to do it exactly, but it's -2 regardless. So now we just change this to -2. So, and we can just move this -2 to the other side. 3 times -2 is 6, -3, I mean, and then -2 is 4. So the y-intercept is 0, 4. So that's all you have to do. It seemed like it took a long time, but that's all you have to do. And then so then we have domain. Domain, how you find that is, well, remember we said that we can't have a radical. We can't have a radical that would have a negative number. We can't have a fraction that would have a 0 denominator, but we don't have either of those things. But also our argument, which is this thing that's in the parentheses, that can't be 0 or less than 0 either. So our argument must be greater than 0. So let's set our argument greater than 0. So that means that it's got to be, oh wait, sorry, that's the wrong thing, because we had that. So we can just set our original argument, which was 9 minus x. So now we have this, and when you divide by the negative, it changes the sign. So x has to be less than 9. So that means that our domain is -infinity to 9. Range is always all real numbers for this, so graph it, okay. All right, we had a asymptote here. That's what we had. We had a y-intercept here. We established that it has reflections, but all you need to know is the direction. Is it going to be going like this or like this? Well, it's going to go like the second one I said, because we know that's what our decreasing function looks like if it has the 2 reflections. So keep in mind the reflections, the transformations, but didn't have time to go through that right now. But that's what it would look like. And then the end behavior, we can say as x goes to -infinity, y goes to +infinity. Sometimes you might write it as limits, but I'm not going to right now. As x goes to +infinity, y does not exist because x doesn't go to +infinity. So that's it for graphing logarithmic functions. It's really no different than any other thing. So that's it for this video. Thanks for watching, and I'll see you in the next one.